try to understand the concept of MOS transistor transconductance. So we know that according to the Ohm's law, V equal to I into R. R can be written as V by I. So conductance is something denoted with G, which is reciprocal of resistance. So it becomes I by V. So this is the relation which we need to use in order to derive the expression for transconductance in both saturation region as well as linear region. So transconductance Gm is something which is ratio of change in Ids with respect to Vgs, whereas Vds will be constant. So it is Ids with respect to Vgs, whereas Vds is kept as constant. Here Ids is output current, Vgs is input voltage, and Vds is output voltage. So in order to derive this particular expression, we need to know about the current equations for both saturation as well as linear region. We know that in linear region, the expression which we got for Ids is mu n C ox W by L Vgs minus Vth into Vds minus Vds square by 2. So this is the equation for current which we got. Now simply do the differentiation with respect to Vgs so that we can derive the expression for transconductance Gm. So differentiating Ids with respect to Vgs. So this is mu n C ox W by L. So try to multiply them internally. So it is Vgs into Vds minus Vth into Vds minus Vds square by 2. Now this is Ids with respect to Vgs. So mu n C ox W by L is again constant. Try to apply U dot V rule. So Vgs is kept constant. So differentiating with respect to Vgs, this part will be 0 plus Vds into differentiating Vgs, this one will be 1 minus Vth is kept constant. Differentiating of Vds will be 0 plus Vds into 0 minus this part will be 0. So transconductance Gm is equal to Ids Vgs. This one will be mu n C ox W by L. So this part got deleted. This one is 0, this one is 0. So the leftover part is Vds. So this is a relationship for linear region. For linear region, this is the transconductance which you got. If you want, you can replace mu n C ox with K. K is equal to mu n C ox. If you want it with respect to K, you can write it like this. It is K into W by L Vds. If not, you can replace K into W by L with beta. So you can also write it like this. It is beta into Vds. So either of these three relations are correct. Either you can go with this one or this one or this one. Anything is fine. So we are done with linear region. Now let us take the current equation in saturation region. So in saturation region, we got Ids as mu n C ox W by L Vgs minus Vth whole square by 2. We got this relation by substituting Vds is equal to Vgs minus Vth in linear equation. So now for this I want transconductance, which is Gm. So transconductance Gm is equal to differentiating Ids with respect to Vgs. This will be mu n Cox W by L. So this is of the form x power n, which can be written as n into x power n minus 1. So it is 2 into Vgs minus Vth n minus 1 into internal differentiation. So this part will be 1 minus 0 whole divided by 2. So this 2 and 2 gets cancelled. So Gm is equal to Ids Vgs. This one will be again mu n Cox W by L Vgs minus Vth. If you want to replace mu n Cox with k, so it is k into W by L Vgs minus Vth or beta into Vgs minus Vth. So either of the three answers are correct for transconductance Gm, but this one is for saturation region, whereas the previous one we did it for linear region.